Under 8.5, we are going to learn how to find the cumulative distribution function for a discrete random variable. And there are some two statements or points there that we must know. The first one, if a particular value of x is small x, the probability that x is less than or equals to x is written as the probability that x is less than or equals to x is written as the function or fx. And fx is found by adding together all the probabilities for those outcomes that are equal to or is less than x. And of course, this is how it is written. Point number 2, like a probability distribution, a cumulative distribution function can be written as a table. Note the presence of the word cumulative, and I will explain why we are calling it cumulative distribution function. This will be explained in example 7 on page 157, which says, two fair coins are tossed, and x, capital X, is the number of heads showing on the two coins. Draw up a table to show the cumulative distribution function for x. Now, you have been told that there is coin 1 and coin 2. And this one is not complicated. Coin 1 can show a head. Coin 2 can show a head. Coin 1 can show a head. Coin 2 can show a tail. Coin 1 can show a tail, while 2 is showing a head. And even both coins can show a tail. That is the sample space. What if you come with the number of heads? The number of heads. And this is now our x, the number of heads. What about the probability that x is equals to x? The probability of the number of heads. Of course, it is true that we can have 0 heads. Yes, it is true that we can have 0 heads. It is true that you can have 1 head. It is true that you can have 2 heads. What is the probability that you can have 0 heads? Here, we don't have any heads. So, 1 out of 4, which is 0.25, which is a quarter. What is the probability that we can have 2 heads? That we can have 1 head rather. We have 1 head there and 1 head there. So 2 out of 1 is simply a half, 0.5. What is the probability that we can have 2 heads? We can only have 2 heads at that particular point, and the probability is 1 out of 4, which is 0.25. And the question is, draw up a table to show the cumulative distribution function for x. And we have had that from statement number 1 on page 156. If a particular value of x is small x, the probability that x is less than or equals to x is written as fx. And of course, fx is found by adding together, and this is the most important, all the probabilities for those outcomes that are equals to or less than x. And this is written that way. So cumulatively. Let us talk about now the fx. Cumulatively, if you talk about the fx1, it's just the fx0 is just itself, because here we are looking at the probability that x is 0 or anything less than 0. Of course, there is nothing less than 0, so x the probability of x being 0 is the same as the function of x, so 0.25. But I want us to talk about the function of 1. The function of 1 means x is 1 or anything less than 1. That means it is accommodating even 1. So we are talking about the probability of x being less than or equals to 1. That means before we came to 1, we had a 0. That means we are allowing our x to be 0. So we are accommodating both values 0 and 1. That means the probability of this or this is the sum of this or plus is the sum of this and this, because both of them are inclusive. So 0.25 plus 0.5 is 0.75. And if you look at this value, 0.75 is the sum of this plus this. Let's go to the probability of x less than or equals to 2. That means the upper boundary is 2. Anything less than 0 is acceptable. So we could have 0, we could have 1, we could have 2 heads. And all of them, it means 0 or 1 head or 2 heads. Meaning 0.25 plus 0.5 plus 0.25, which is basically a 1. Cumulatively, how? You can already see that this value is the sum of the first two values. And this last value here, which is the fx, is the sum of all the values. This plus this plus this. So they continue to pile up cumulatively. And that is why we are being told that it is the sum of all the values of x or less than x cumulatively. And that is we have been able to elaborate the cumulative distribution function of x, or rather fx. All right.